Okay, so Unit 2, we discussed kind of some of the basics of the atom so far, but a big chunk at the beginning of Unit 2 is kind of getting us to the point of how we know the atom is made out of protons, neutrons, and electrons, and all the important scientists who led to our understanding of what the atom is now. So these two lessons are really important as far as making sure you read them and recognizing, tying a scientist's name to their contribution of the atom, that sort of thing. So I've put together a extra credit assignment that you can complete that will also be a cheat sheet for you when you take tests and quizzes, that sort of thing. And I just want to describe how to do that. So you're going to set up a table like this. All right, you're going to have 5 at least rows going down. There's actually 6, maybe 7 scientists that are actually covered in there, but you have to get 5 of them. And what you're going to do is you're going to put their name, what they used, like what experiment they did or something like that, or what tools they were able to use, what they were studying, and then what their contribution to our atomic model is. All right, so for example, I pulled this right out of your reading. This is the first scientist that is discussed. All right, so the concept of the atom goes back to more than 2,000 years to the Greek philosopher Democritus. All right, so that's the scientist's name. There, he's a philosopher. All right, and read further to get some of the details. All right, so Democritus wondered whether matter was continuous, meaning could it be cut or divided into infinitely small pieces? Was there something that couldn't be broken down further? All right, so he hypothesized particles that he called atomos. All right, so this is where the word atom comes from. And that actually means indivisible. All right, so not invisible, but indivisible, meaning it can't be broken down further. That at some point, if you break matter down so tiny, you're going to hit something that you can't break down further. All right, so that's Democritus defined an atom. That's his contribution. All right, so if you were filling out that table, the first box would be Democritus. The second box would be really that he's just doing mind experiments, because at this point he didn't have any tools to actually test this. So he's just, thinking critically, trying to figure out more information than he knows. But he does, and talking 2,000 years ago, he doesn't have much as far as technology to test this. All right, so his studies are just mind experiments, that sort of thing, and his contribution is he defined the atom. Another one, and this shows up in lesson 2.02. I really like this experiment, and I want to make sure you have a good understanding on it, because it's the reason why we know that essentially the atom is pretty much empty. All right, so Rutherford. So this is more 20th century sort of stuff. So we finally have technologies that we can use to test atoms and figure out what they are. Rutherford took this alpha particle emitter. All right, you don't necessarily need all these details. You're fine just remembering that Rutherford has this gold foil experiment. I just really like this experiment, so I want to explain it to you guys. So he took this alpha particle emitter, which just shoots little helium nuclei. So, all right, so you can't see this. All right, but we know it's happening because there's this detecting screen that'll know that if these nuclei hit it. So we know there's stuff coming out. The screen can detect that they're there. We just can't see it with our eyes. And he shoots these alpha particles at this really thin layer of gold foil. It's only a few atoms thick. All right, and then he just measured where the alpha particles hit the detecting screen. All right, if you remove the gold foil, all the alpha particles are going to hit back here. All right, you put the gold foil in there, almost all of the alpha particles still hit in the back there. But there's a few that are deflected some, a few, even fewer, like only a couple that are deflected greatly. All right, but still most of them just go right through. All right, so really what's happening, this is kind of a blown up model of what's going on, is a lot of the particles are they're passing through empty space. Some of them are coming really close to, what's that black thing in the center there? Hopefully you're thinking the nucleus. So some of them come really close to the nucleus, all right, and get deflected a little bit. if it just kind of gets close, or if it happens to hit it smack dab right on, then that's the ones that get deflected greatly. All right, so Rutherford, his gold foil experiment, he discovered the nucleus. All right, he discovered that, one, there is something in the center of the atom there, because we did get them deflecting, but it's small, it's really dense, and most of the atom is empty space. All right, the little deflection that was caused as some things got close was because the nuclei are positive, and they repel each other a little bit. All right. So if you were filling out your table for Rutherford, you've got his name is Rutherford, his experiment is that gold foil experiment, and then he discovered that the nucleus was this small, densely, positively charged thing at the center of the atom surrounded by a bunch of empty space. All right, so just that table that you want to create. My suggestion is to get these experimenters down. These are the ones that I know are going to end up showing up later on tests and quizzes. But get this table filled out, and then you can turn it in after the 2.04 quiz for 5 points of extra credit.